welcome to this panel on security challenges in 5G wireless and beyond. I'm Sundeep Rangan at NYU, and I'm joined by my colleague Siddharth Garg, who will be moderating today's discussion as part of the Seesaw panel event. So you've heard a lot, I'm sure, everybody here about 5G networks, and they supposed to offer at least a number of new services, much higher data rates, much greater numbers of users, low latency services, cloud access, but these very services are also present their own security risks. We have cloud services being deployed in the network itself. There's disaggregation, which means much larger numbers of components. The networks are collecting large amounts of data on users for their management. And we also have all sorts of new attacks and disuse of the spectrum, particularly in the millimeter wave bands. So today's topic is, can we make these networks secure? What do we mean by security? And how do we actually go about doing this? So to do this, we have a great set of 6 panelists. I'm just going to walk through and have each one of them give a short chance to introduce themselves, and then we'll get hit right into questions. Just a little bit about logistics. If you have any questions, please just go ahead and either put them into the question of answer box. You can also put them in the chat, or you can just speak up if you're brave enough to do that. I'm really encouraging everybody to participate and get as much discussion going as possible. All right. Just before we go on, I want to thank all the sponsors, first of all, for all the amazing organization at Seesaw, this event. Wish this could have been held in person, and maybe next year we'll have a follow-up that can do this if we get beyond COVID. This is also joint work with the Center for Cybersecurity at NYU and the Center for NYU Wireless, with our large number of affiliate companies. Couple of them are here actually representative, as well as our federal agencies, of which we also have representatives at this panel. All right, so let me just get a quick opening statement for our 2 amazing panelists from industry. Let's start with Michael, who's a principal researcher at Ericsson. Maybe Michael, you could just introduce yourself quickly and tell me what you think about what's worrying you about security, and what's the most exciting technologies that you're interested in.
Yes, thank you, Sundeep. So I'm a principal researcher. I've been with Ericsson for more than 10 years. I've worked on mainly in network security, cellular infrastructure. More recently, I'm also looking more at AI, ML, and security in relation to the network infrastructure, and also some topics in trusted computing. So for our topic today, I mean, I would say we start with 5G and what's being deployed today. The security is good. We've made several important enhancements in 5G compared to previous generations in areas like protection of signaling, user plane traffic over the air interface, also privacy enhancements, protecting subscription privacy, and enhanced protection of roaming interfaces, just to name a few. So I think that there are a lot of, there's more work, of course, continuously going on to extend on that and make enhancements. But as we look forward to like the next generation, and currently we're sort of starting to look at what that could be more concretely. There are, of course, also more opportunities to more fundamentally make improvements, not only to things like capacity, capabilities, flexibility, but also to security and privacy, where in cases where we identified gaps, or we can see that that would be good to make enhancements. So overall, I think that there are new, challenging use cases being discussed, and that we want to support. But my overall outlook is optimistic. We have more good things to add to this.
All right. Thanks a lot, Michael. And our next industry panelist is Vish, who's a VP of Technology Strategy at the CTO's office at Dell. Vish.
Thanks, Sundeep. Yep, as you'd mentioned earlier, I'm the VP of Technology Strategy at Dell. I've been at Dell for about 3.5 years, and prior to that, held a number of different roles in telecoms, ranging from Nortel, Ericsson, and on the operator side as well. as I look into 5G, it's an exciting time. For much of the iterations of the different cellular generations, we've kind of been playing a game of identifying issues and threats, and then taking an approach to resolving them, which quite frankly is a bit of a messy way to approach security. The posture moving into 5G was much more, let's take a framework-based approach. I think, as Michael had mentioned, there's a lot better privacy-preserving techniques, particularly in terms of being able to transmit things, identifiers and such, in the clear versus having them ciphered appropriately. There's much more attention to roaming interfaces and taking zero trust approaches between home and visited networks. Particularly as we take a look at some of the techniques applied to data integrity on the user plane, and being able to kind of filter out malformed packets, those types of capabilities. All of them have kind of found their way into the new 5G security framework. I think what's exciting is really, where we're taking 5G next, which is going to expose us to new environments, particularly as we take a look at the advances in the private cellular space, moving into enterprises, particularly in sensitive industries like manufacturing and healthcare, taking a look at what kind of security assurances those industries are going to need, which are going to need to extend and build on top of the existing 5G framework, is of particular importance to us. I think the other areas which are going to present as challenges is 5G comes with some fairly distinct new architectural frameworks, particularly as we look to disaggregate the infrastructure and create a virtualization layer to separate concerns between the application and the underlying performance layer. That starts to open up the attack surfaces. As you look at some of the protocols that are being leveraged, which are prevalent within the web world, it also kind of starts to lower the barrier in terms of the amount of attackers who are familiar with these protocols, that need to be defended against. So it's an interesting time where I feel that the industry has done a lot to address some of the security issues, but we're now hurdling ourselves into new environments, and we're taking on new architectures, all of which now need to be accommodated for.
Okay, great.
Excellent. So on to the academics. When we were trying to put together this panel, we were thinking of the people who've done the most impactful work from academia in this area, and we couldn't think of two better people than Syed and Christina. So we're very happy that they could both join us. Syed is an assistant professor at Penn State University. He's won several Best Paper Awards for the work that he's done in the space of wireless security, next generation, and 5G security. And he's received the Hall of Fame award. He's part of the Hall of Fame for GSMA. So Syed, we're happy to have you, and excited to hear your thoughts.
Thanks, Siddharth. Thanks for having me all, and good to see you all. So as Siddharth mentioned, I'm an assistant professor at Penn State. My research interest broadly lies in security, systems and network security. Over the last several years, I have been working on 4G and 5G network security. So my take on 5G security or NextG security would be something like that most of the time so far, we have been considering security as an afterthought. Means that we consider security after assuring functionality or performance of the networks. And we, as Vish also mentioned, that sort of retroactive security that we have been looking, we need to change that paradigm. So retroactive security, by that term, I want to refer that so ad hoc patch based analysis or fix finding the vulnerabilities and then patch it, rather than going through in that direction. We should move, we should take a step back and see that how we can do better from the ground up. Means that when we design the NextG systems or 5G systems, I mean, what are the threat models? What can go wrong? Even some systems being compromised. So if we don't consider some kind of threat models from the very beginning, then at the end, what will happen that we deploy some systems, and then even for 5G, I can give one example that both me and Christina, we have some kind of findings, shared findings about IMZ cracking. Like in 5G, we have introduced public key encryption to conceal our the long-lived identifier. Sometimes we call it SUPY, SUPY, subscription permanent identifier. We claim that 5G introduced public key encryption that then it's better than previous generations. But things can go wrong when public key or crypto algorithms meet with systems. It's more about not giving doubts about the crypto. It's giving doubt about when that crypto is incorporated into the complex systems. So we need to make sure that those kind of issues don't exist during the design time. After deployment, things are very hard to change. And why it is hard to change? Because it's not a kind of a simple software or hardware deployments. It's a multi-trillion-dollar business. So if you want to change one thing, one line of code, it has to be approved by, all the stakeholders. Secondly, my concern is that 5G has brought up many new directions, but at the same time, at the protocol level, if you look at the protocol level, there are so many features that have been inherited from the 4G networks or 3G networks. For example, the initial registration procedure that you turn on your phone and you connect to the network. Most of the features are similar, even including the security features. So that means those kind of features which might be vulnerable in the 4G or 3G that have been inherited in 5G or NextG. So we need to think about that from that perspective. And when we incorporate the old features, I'm not saying all the old features are bad or vulnerable. We need to make sure that all the features that are being incorporated in 5G systems will be secure by design. So what I'm trying to propose essentially is that what my argument is that we need to incorporate design time verification and testing from the very ground up so that we can make our system secure, NextG systems. Yep, that's it.
Thank you, Syed. There was a question about the background music. So I'm very sorry about that. Like many of you, I'm working from home and there's a concert in the park. So this is the quietest place I could find. I will try to minimize the amount of time my microphone is on. But I'm sorry, there's not a lot I can do about the background music other than ask all of you to enjoy it as well. Our next speaker is Christina Pöpper, who is an assistant professor of computer science at NYU, Abu Dhabi, where she heads the cybersecurity and privacy lab and does some truly amazing work in this area. So take it away, Christina, and thank you so much for being here.
Thanks a lot, Siddharth, and hello, everybody. It's amazing to join this group of people. A few words about myself. So I'm a cybersecurity researcher in general. I've been focusing a lot on wireless security for various systems, and one of the systems, and probably the most important systems of the one that we investigated, are cellular networks. Together with a group of amazing students, we have been able to make contributions in particular to 4G security in the past, where we've been able to do, for example, attacks, coined the Ultra attacks, that allowed to impersonate 4G traffic, so 4G communication, where we could impersonate as users basically by attacking the systems. We've also done works where we've been able to eavesdrop on encrypted voice over LTE communications in 4G networks. And what is very exciting about the area in general right now is, like with 5G, is that there are a lot of, from the academic perspective, from the academic research perspective, there are a lot of new opportunities of what we can explore and should explore and need to explore in the systems that are being deployed at the moment. that it's exciting from the perspective that on the one hand, as also Michael mentioned at the beginning, we have systems where security, a number of strong security mechanisms have been put in place. So the systems are in generally first can be considered to provide a relatively good level of security. We have specifications for only the security of 5G systems that are hundreds of pages long. So a lot of thinking went into that. I would say that on like the protocol level regarding key agreements that are used for later encryption, for example, we have kind of solid systems in place that have been analyzed and that where we kind of understand that reasonably. But the ecosystems are huge, and a lot of vulnerabilities and security weaknesses actually come into place when we look at the 5G ecosystems as a whole. There are new interesting aspects of 5G as opposed to the previous generations. There are a lot that I could mention. I'm just want to mention things like eSIM, for example, the embedded SIM, which provides interesting perspective that a user would not have to change SIM cards when, for example, roaming and going to another country. You would have a SIM that's that can be remotely provisioned by the providers that whoever is wherever you're going, basically. But this may have implications, for example, on location privacy as one of the examples. So it's also the way how they're using the new 5G technology by using millimeter wave communication, where the cell sizes are smaller, has implications on location privacy, as an example. And another point that I would like to bring up is what is exciting, what is interesting for me to look at or to see in the future, how also industry is taking up aspects of using machine learning in the deployment of 5G systems for various reasons. Machine learning has huge potential to provide better services, which cannot be handled individually, but the security implications of those are not clear. I guess we might come into that a bit later in the discussion here, but this is going to be one of the exciting areas to look further into from the research perspective.
We're also very lucky to have two federal agencies. Let me start with Robinson Pino at the at the Department of Energy. Maybe you can just quickly introduce yourself and what excites you, Robinson.
Hi, how are you, everyone? It's a pleasure to be in this panel. One of the things that are exciting for us with respect to advanced wireless and 5G is all the new capabilities that are going to be enabled with 5G, from ultra-reliable communications, higher bandwidth, low latency, network splicing, and that we believe that there will be a lot of opportunities for really using wireless networks the way that we have not been able to use in prior generations. And so we have been looking at advanced wireless for about 2 years now, and this calendar year, last fiscal year, we started some projects within the DOE National Laboratories focusing on 5G. Many aspects of how could we use 5G within a scientific enterprise. And we have projects that are looking at 5G in how it could be used for management of the power grid. How could we use 5G with autonomous drones for wildfire studies and prediction? How could we use 5G and blockchain for security and privacy? And another one, how could we use 5G with advanced edge sensors that leverage a lot of AI for distributed sensing? And there is a lot of excitement in terms of the new technology that is being rolled out that provides a significant improvement. Almost maybe competing with what we can achieve through a wired connection. In addition to that, given that as we are able to connect to the edge with advanced wireless, so now edge will become or becomes more relevant. And we've started a microelectronics initiative in DOE that is looking into how we could revolutionize microelectronics for multiple applications. That would include edge computing and wireless applications. So I think that the future for research and the resulting challenges of having more capable wireless networks are going to be very interesting and exciting. And I believe many more opportunities are going to be coming online in the not very distant future. So thank you all.
Thank you very much, Robinson. Last but not least, James Wilson, who's joining us from the MTO.
Thank you. Yeah, so James Wilson, I'm a program manager in the Microsystems Technology Office at DARPA. 5G is extremely exciting for me and DARPA at large because it's really been enabled by the commercialization and the development of techniques and components and systems and transistors that DARPA has been investing in for the last 20 or 30 years. And you've been able to take it from something that is an exquisite, super expensive, high-end capability for the military and squeeze the cost down that you can actually commercialize it and use it for 5G and 6G communication systems, which is just super amazing. For me personally, I come from the RF analog digital circuits. I'm an ASICs guy. And I have a program that's been running here at DARPA for the last 5 years or so. It's called Obfuscated Manufacturing for GPS. And it was getting after, can you do logic locking of digital circuits to prevent their use to detect Trojan insertions. And when I picked this up, it really was the program really was trying to plug the holes in the dam while the dam was crumbling around you. You would come up with one technique and you would publish it, and 9 months later, a different research group would come out with an attack for it and publish it that they broke it. And then 9 months later, you would have your publication saying, no, we've addressed that. It's not that big a deal. And you would just go back and forth. And what we want to do, I have a new start that we're working on, that we want to take a step back from that and address this much like some of the previous panelists have said, is we take a larger scope and what can we do with hardware security? Can we create a formal proof for hardware security, all of what you do for a cryptographic proof? And then can you take that and the assumptions that you have to wrap around that proof and map those into actual hardware so that you can get a handle on how long will your hardware be secure when it's in the field before attack techniques have developed enough that you can then go and break it. And this really gets after addressing the assumptions that underlie how we build security today. Everybody knows it's a layered approach, and all the way down at the very bottom of that layer, you have your hardware. And within that hardware, you have the keys that form a public-private key pair. And if somebody can pull those keys out of your hardware, the whole system that is built upon that falls down. So really, it's about trying to get after how do we protect those keys. I'll stop there.
All right, thanks a lot to all our panelists. So I have some questions, but we already got some questions from the audience. So maybe I'll just grab one of them. If anyone wants to take a shot at this, Dyer is asking, with increased data rates in 5G, will encryption and decryption technology be adequate to deal with the higher conversion rate requirements, or will it be a bottleneck? So maybe that's a bit of a hardware question if anyone wants to take a shot at that on encryption data rates. Yeah, so obviously the rates are going to be very, very high in at these data rates, taking by perhaps even into the gigabits per second. But I suspect that the other processing parts are going to have to scale equally. So encryption is going to be hard, but so are all the other parts. So maybe we'll come back to that later. So maybe I wanted to follow back up with Michael. You mentioned, as I guess Fish has did well, about topic of disaggregation. Maybe for some of the panelists, for some of the audience members who are not as familiar with 5G networks, maybe you can just quickly explain, Michael, what you meant by disaggregation and how it is or what are the security threats with that?
Yeah, thanks, Sundeep. So I think it has been mentioned sort of in two contexts. Or one, the main thing I would think about is disaggregation of network functions, where you split larger functions into smaller pieces that interact. And we have an example of that, for instance, in the 5G service-based architecture in the 5G core that was re-architected compared to 4G. Right? So it's divided into smaller functions that interact. And that creates more interfaces, more points of interaction, of course, and that can have an implication for security as well. You need to make sure to put appropriate security measures in place. Since you increase the possible threat surface, you need to make sure to have appropriate detections, and that has been defined. There's authentication authorization for the different APIs in the core, and there's protection of the communications between the network functions. Another example that's being discussed as well is disaggregating the radio access network, an Open RAN initiative. And I think there are similar, there's similar aspects there. You split the RAN functions into smaller functions, you expose more interfaces. You need to make sure that you have appropriate protections in place as well. So we can deal with that. There's sort of classic security functions that we can put in. There could potentially be some opportunities as well. At those control points, you can also put in increased monitoring, possibly enforcement. I think that's something to look into further, perhaps to study further, if that can be leveraged. I think Christina mentioned the use of machine learning to enhance security monitoring, and that's also, that there's could be an opportunity for using that in that context as well.
Okay. So there are several questions on chat, Sundeep, if you want to take them. I think there are several interesting questions, actually.
Yeah, sure. I'll get to them. Maybe just want to
on the Q&A. Sorry.
No, I will definitely get to those. On this topic, though, so it sounds, Michael, that you're pretty confident that with the current security authentication procedures, that disaggregation is not much of a worry. Do any of the other panelists are roughly in agreement with that, or? Topic of this,
I think at least there are the many things that we know how to do and deal with, and I'm not excluding the possibility of looking sort of deeper if there are other aspects to it that deserves attention. But
all right, so we have another topic. I'm not sure if this is in the domain of anybody here on the panel, on physical layer security. This what is your take? This is from Suresh. What's your take on physical layer security versus security at the application layer, and will future networks end up having both? So I think physical layer security, we haven't seen it yet come into commercial networks. Is that on the radar of anyone here?
So I can
please go ahead.
Probably Christina can add. So though I didn't explore the physical layer security, but one of the primary concerns is the denial of service attacks, because physical layer is shared with the trusted and untrusted parties, and any untrusted party can, even for 5G, can at least connect to the base station. So for connecting to the base station, you don't need any kind of authentication mechanism. So at the physical layer, you can sort of jam the network, either in a very brute force way, or you can jam the, you can consume, as an attacker, someone can consume the physical layer resources. So this is one of the primary concerns at the physical layer. And some of the other concerns are, for example, some kind of fingerprinting. Fingerprinting could be in the form of website fingerprinting. It could be movement tracking, because 5G is going to, it is millimeter wave range, and the range of the base stations will be much smaller compared to previous generations. And at the physical layer, the tracking, unauthorized tracking of the users can be done more efficiently than the previous generations. Regarding the application layer security, 5G the one big new innovation for 5G is it is exposing many different or enabling many different applications, for example, telemedicine or manufacturing, right? So we don't know what is the security or privacy vulnerabilities at that level, but that is one good opportunity to explore.
There are several questions in chat, but just to quickly follow up on something that Syed said, and I think Christina also brought up about location privacy and smaller cell sizes. I mean, there's clearly a fundamental tension here between, location privacy, users, essentially exposing their locations to network operators, not only to unauthorized components, and at the same time, the desire of network operators to provide higher throughput, higher performance, right? So, does anybody have thoughts on if there are ways to, Christina, for example, you brought it up as a concern. Do you have thoughts on how you can, or any of the panelists, on whether this tension can be mitigated somehow? Because it appears as if location privacy, at least in 5G and highly directional communications, is almost definitionally going to be compromised, right? So what do we do about that? If anything, I mean, I have some thoughts on that myself, but yeah, maybe.
I'll let Michael go first, but I have 2 comments that I would like to make on the previous 2 questions. But
Yes, please.
First on this question, and then I jump in.
Right, fantastic.
So I was just thinking that there's a lot of interesting work being done in privacy-enhancing technology. So we're looking at things like confidential computing, cryptographic methods, and so on. And I certainly think that there's more opportunity to I think leverage those techniques and see what we can do to enhance also the protection of location information inside the network itself and limit how it's where it's being exposed and so on.
Yeah, thank you. That's an excellent point. I was just gonna, I think some of these methods, expose privacy and utility trade-offs. So I think one of the things that network operators at some point will have to grapple with is, what is the utility trade-off that you're making to provide greater privacy? But customers are demanding privacy, and I think that might be.
Christina, do you want to?
Right. Thanks, Sundeep. I wanted to go to 2 questions that were asked before regarding the physical layer security. So I fully agree with Syed's answer on the risks regarding jamming, physical layer attacks, denial of service attacks. There's also the aspect of physical layer security where actually the physical layer would, at least in the academic world, what we have where this would be used for security purposes, for establishing secure keys between remote parties, for example, that measure the channel and the channel response and try to extract keys from that. That is a very interesting concept. As far as I'm aware, that's not something that is in place currently or that's being used, but there are also opportunities in that. They might need, I'm not sure how we will get there for the widespread deployment, but these are additional concepts that are interesting to explore. And I wanted to make a second comment on the earlier question, if actually our systems, if the encryption can live up to the expectations in terms of bandwidth, what we are expecting. And my answer to that is, on the one hand, what is used for encryption of large scale data traffic are symmetric schemes that are very, very efficient when it comes to hardware implementation. So basically stream ciphers are very efficient to be implemented. So we can support very, very high data rates for that. But I still want to acknowledge the fact that there may be very short delays that are still being, that can still be, have a certain preventing factor of things to be deployed on the large scale. And the example that I want to give for that is, as was previously pointed out, there are current weaknesses regarding the integrity protection of user plane traffic. We have made major advancements from 4G to 5G in the sense that in 5G now, it is mandatory that the providers actually support integrity protection on the user plane traffic, so on the data traffic that users send, but it's not necessarily compulsory to have them activated all the time. So as from the user side, there's no guarantee that actually the user plane traffic is encrypted. We've been in communications with the standardization bodies about that. The answers that we got so far is one of the reasons why this was not put as a mandatory requirement is worries about the very short delays that this might incur. So my summary on that is that I would say yes, in general, hardware implementations are very efficient to support very high data rates, but there may be some very small delays that still would be noticeable and might prevent some of the realization of security mechanisms that we are aware of.
All right, great. Maybe back actually on that, I think we're also seeing some other things about the design challenges in millimeter wave 5G, going back to this location. One of the aspects that interests me is the directionality, the directional nature of these communications that make the networks fundamentally more secure in a way, because attacks can only be limited in certain directions over very wide bandwidths. Do you have a feeling that in that sense, the wide bandwidths can actually be beneficial or harder to take down from a network standpoint? If anyone wants to take a shot at that.
Yeah, that seems, it will be helpful, right? Both in terms of it makes it harder to eavesdrop, to pick up any communication. And if you have a very tight directional communication, it will be more difficult also to interfere. I think jamming was mentioned earlier. So I think that there are definitely positive upsides to that.
Okay.
Yeah, the assumption that you have more security from a highly directional beam steering array is a common one, but it's not always guaranteed, right? So if you are doing a long distance link, you use the antenna array gain to help close that link, and that's what you're going to do with a millimeter wave beam steerer. And that's great because you're at a higher frequency, so you can put more antenna elements closer together so you can get a higher array gain. But what happens is that you will still have side lobes, and you can still get into them through the side lobe. And if your gain is up high enough that you're trying to talk to someone very far away, you don't have to be far away to eavesdrop. You can be right up next to the tower and get in with a low power transmitter on a side lobe. So the security doesn't go away just because you're using a directional antenna.
Yeah, completely agree with that, if I can jump in there. So I completely agree with you, James. I mean, I don't think it obviates the need for the other security mechanisms that we have already, but it still constrains where you need to be positioned, I think, to be able to either eavesdrop or to inject noise.
Absolutely, I agree. Yeah.
There's an excellent question in the chat about, which I'll kind of generalize to the question of the supply chain and the hardware, the supply chain. In this specific, it mentions supply chain from China, but I think it's a more general problem about a diversified global supply chain and how that's going to impact security in the future. So I was wondering if somebody wants to comment on that, or we can defer that question till maybe you have another one, Sundeep.
We can always go back to that. So I think both Robinson and James, you've been looking a lot at supply chain hardware security. This question is specifically about market penetration of Chinese Communist Party. I don't want to get into a political discussion on that topic, but maybe just at a tactical level, like Siddharth said, just in general about what we can do about in a diversified supply chain. That's been obviously a big political topic with at least the US network infrastructure. James or Robinson, you maybe want to jump in about this?
Or maybe even the industry folks, right? To what extent are you guys concerned about this supply chain diversification kind of impacting the security of your network components?
Yeah, definitely it's a new concern. I think when we look at security assurance across the supply chain, we're going to need to take into account some new methods, especially, if all the components aren't going to be delivered by a single source, but you have multi-sources that you have to deal with. We're going to need some level of new accreditation for, vendors, design methodologies. We're going to need test lab certifications and accreditations. There are some of these that are being produced by consortia like GSMA. You also have some that are being provided in terms of test cases by 3GPP. But I think it's going to be a point of concern, especially for the system integrators in some of these Open RAN capabilities that are being delivered as kind of next generation architectures. And this has to do with, how do you accept software from an upstream supplier? How do you make sure that it's stable, it's robust, that it's resistant to the suite of threats that you're monitoring for? It's a zero trust kind of supply chain that has to be put in, where you don't accept anything on face value. It's going to have to go through a set of automated procedures hooked into your CI/CD pipelines that ultimately deliver down to the target when it's deployed. That's a whole new set of methodologies that otherwise we wouldn't have had to have dealt with when you had everything really delivered by a single source. So these are new types of capabilities that are really only rearing their heads here in 5G.
Vish, I just want to follow up on that. From an industry perspective, is it fair to say what you're looking at are topics about the reliability or the quality of the software, but is it fair to say also that you're not explicitly worried that there's a malicious entity that might maliciously manipulate either the software or hardware?
Yeah, absolutely. All of those things need to be considered. From a Dell perspective, obviously, we're specializing on the performance layer and the servers over which much of the software is deployed. So for us, it starts with infrastructure level security, having proper PPMs in place, ensuring secure booting, but also more and more we're looking at across the life cycle of the code execution. How do we ensure that infrastructure is still secure? When you kind of move away from just a platform-based security and you look at the different functions that are being deployed on top of that infrastructure, because it's abstracted, you now have potential for new types of issues. For instance, there's a lot of circular dependencies that become manifest in those types of environments that have to be audited for. So there are some concerns that really kind of manifest themselves in the implementation of these systems that we need to worry about. I think the other area, kind of pulling away, which is a traditional problem in commercial networks, is really around configuration issues. About 1 in 3 successful attacks tend to be configuration errors, and that becomes multiplied when you work in a system where you have multiple different autonomous services that are running and being stitched together, each of which have to be configured appropriately, not just in terms of the structure of the application code itself and its disaggregated nature, but also in terms of the layers. So now I've got a hypervisor layer sitting on top of my hardware, and I've got some type of container management system on top of that. I might have serverless capability. I now have to understand how each of those layers interact and are monitored in addition to the application. So the ability to get sufficient observability across that stack and to do event correlation and analytics to detect for attacks that are imminent or occurring becomes very, very important. So that also starts to blow up an area that otherwise we wouldn't have had to deal with so meticulously.
Can I just quickly follow up? So I heard a phrase that caught my attention that I've heard a few times before. Vishy said zero trust, right? And as academics, I think that our definitions of zero trust can be different from perhaps what zero trust might mean in industry or perhaps even in defense. So I was wondering if you could just maybe what does zero trust mean for you or for the other folks on the panel?
Yeah, it's really this concept of least privilege. It's ensuring that a system can't really try to assume privileges beyond what it needs to access for a particular service. When I was talking about zero trust, I was talking more from the perspective of a literal interpretation of that between a system integrator and an upstream supplier of software. We shouldn't just accept their software at face value. It needs to be authenticated. It needs to be tested for any vulnerabilities that could, impact the security doctrine or security framework that you're delivering into. But hopefully that gives you a sense of what I was talking about.
Yeah, the Department of Defense version of Open Trust is pulling the best practices from commercial. So we're doing exactly what Vish was talking about, where you limit user privileges to the minimum set that they need to do their task, and you remove them from the system after they're done, and you add them back when they need to come back in. And then there's the provenance and the tracking of everything that is coming through your supply chain in a zero trust environment. And it's getting all of this set up across a global worldwide network that changes every 6 weeks especially with the department where we have small vendors who are providing unique boutique services and they come in and out of business.
Yeah, if I may add to that, I think from our point of view in Ericsson, I mean, it's also about not assuming trust based on, say, which network which part of a network you're connected to, or your location or things like that, but actually on a very granular level, verifying and authenticating before you permit access to resources, right? And I think there are, so NIST has it described very well in some of their documents, and we've looked at sort of the design principles, for instance, of the 5G core, where we see a good alignment already in some of the ways that things are handled there. And there are also further additions that can be made. And I think, as I mentioned earlier, looking forward to the next generation of system, I think we can expect to see sort of zero trust principles to be embedded right from the start, the definition of the system.
Thank you.
Okay, maybe I'll circle back. We were talking a little bit earlier about directionality and jamming. I want to, that also touches on another topic, which is just the spectrum management. So there's an active area in my community on the air interface side about how multiple operators can share spectrum, potentially into millimeter wave bands, because they're relatively short range and directional. I want to understand but there's operators have had traditionally a lot of hesitancy for a variety of reasons, one being the security implications about that and about monitoring that other parties use the spectrum in a way that's fair. What do you feel about the way industry is going with spectrum sharing, and what are the security risks? Do we have technologies that can enable it? If anybody wants to take a shot at that, or just radio resource management in general?
And I think it's one of those slippery slope things where, you know, some of the advantages of cellular are because that it's, you know, well-governed spectrum and it's dedicated, versus, you know, the experience you could get over the ISM band for Wi-Fi, as a, for instance, where it's, you know, heavily, you know, impacted by interference, as you would no doubt experience if you've ever used a Wi-Fi device. But I think that there are some middle grounds that are possible, and this is where some of the lightly licensed regimes have started to come into place. CBRS with their priority access and GAA licenses, which make use of things like SAS to ensure that, you know, it's all right to actually use the spectrum, such that you don't get interference with other competing networks or other competing services. So I do think that there are middle grounds, and we're starting to see those start to proliferate, not just in the US, but obviously in Germany and other places in the EU. I think that seems to be a good trade space balance between those two extremes.
No one else has a comment on that. I actually want to go back now to a topic that Christina mentioned. You mentioned role of AI and ML, and a couple of other people. I think Michael was saying that was also an area of interest. Just let me start broadly. Christina, what do you think are the role of AI and ML, and how will it influence the way that we're doing security going forward?
Yeah, that's a very great question. So for me, there are two sides of the use of machine learning techniques when it comes to the security of 5G systems. On the one hand, I think we are at the start where ML techniques will be more and more used for a better enabling certain services. This can range from what you have mentioned, network slicing, dynamic allocation of resources, power allocations, channel quality indicators. I can imagine that these are areas where heuristic-based allocations would never work as well as machine learning techniques could support these. And there it becomes very interesting what actually, so from the security perspective, what's the risk of having machine learning techniques deployed? How could they be attacked in view of adversarial examples of attacks that we are aware of in other systems where machine learning is heavily in use? what could actually attackers do there? How could they impact to create unfairness in the allocations or to prevent others from communicating, running a subtle DOS attack, for example? That's very hard to identify then, much harder than simple jamming, which you could more easily detect, obviously. And also like targeting particular parties, for example. So this is one side where I think this is an interesting thing to see how the future evolves. The other aspect is how machine learning techniques could actually be of use for providing better security, for detecting that attacks are taking place. So, for example, if we think of malicious base stations being put up, we would have to kind of monitor what's going on the physical layer. What are the signals, the messages that are being exchanged, and their machine learning techniques could provide some tooling to better observe the systems and have indications of when possible attacks are happening, for example. So this would be the use of machine learning techniques with security goals for the detection and identification of attacks. These are, I guess, the two major directions that come to my mind.
Christina described it very well. There are sort of two sides to this. One is the benefits that we can get from applying machine learning techniques to help with security problems, right? And it's already being used extensively, and looking at the next generation network with sort of cloud native design, things become much more dynamic in interactions, and I think we need more assistance, sort of more automated reasoning about the security of the system. Perhaps try to find ways to make more quick assurance decisions as well as threat monitoring, like Christina mentioned. So it will be very helpful, I think, even needed for to deal with those aspects. Then there's also the other side of it, that not only for security but for many other functions in the network, machine learning and AI is being introduced as a sort of part of solving those problems. And we need to also make sure that we look at the potential risks that it introduces. And I think there's a lot of course, it's a very hot research area, looking at adversarial machine learning and the potential risks, and coming up with good mitigation strategies or building robustness into the system from the start. So there's a lot of work being done, but I think that deserves more study as well. So yeah, there's good potential for using it, and there are things that are being investigated.
I think there's a lot of promise in it, and particularly, as both the panelists mentioned, on the anomaly detection side, it can be used for localization services and detecting jamming attacks or false base stations, those types of things. I think when we've been looking at it to do resource allocation mechanisms, whether it's at layer 2 for scheduling or whether it's for channel estimation services, all of those things, are yielding some great fruit. The concern that I would raise around machine learning is simply that, we're still pretty early when it comes to fielding production machine learning capabilities in the field. And so simple things like, how do you monitor the data pipeline for drift? How do you ensure that as the model itself starts to degrade in quality, that you have to retire it and retrain it? And all of those types of what I would call life cycle types of concerns today aren't really well acquainted by kind of the traditional industry. It's things that can cause concern and can create new types of vulnerabilities in your system that we all have to just get some battle scars to understand before we can actually field them successfully.
Yeah, I think there's a lot of, I think it still needs a lot of work to, because the techniques are still pretty fragile. I want to, on this topic about AI and ML, a related point just about data privacy. Obviously AI and ML, but plus a lot of other network management techniques are relying on aggregating a large amount of data on the network, say for training, channel estimation algorithms, basically any type of method, resource allocation. Where's the tension there between user privacy and data and the operator collecting data? How can we try to resolve that? Does anybody have any thoughts on that topic?
Before we get to that one, I just wanted to comment on the last topic really quickly.
Oh, please.
The chance to plug a program that just wrapped up here that I was running. It's called SPIN, which was Signal Processing in Neural Networks. It was an 18-month program where we had 5 performers who took DSP blocks out of a communication stack and implemented them as lightweight neural networks. trying to do fun things for communication. One of the performers was using this to do noise isolation in an HF link. So think an atmospheric bouncing wave from one side of the planet to the other. And they were able to get 60 dB better than any person could do hand tuning it. And you see similar techniques from other performers doing jammer mitigation and getting 30 to 40 dB better jamming performance out of a signal processing block than a hand-designed exquisite DSP chain. So there is absolutely a lot of surface here for AI and ML to be applied to, specifically where you have noisy background that is confusing for humans to look at, but the machine just sees right through it. And you can actually, what we found is that not all noise is white, and the machine can pull the noise structures apart. The machine learning algorithms, and even in a very lightweight kernel, can pull the noise structure apart, and that makes it much easier to actually get to the real data that's within it.
Very impressive. Yeah, there's been on the physical layer, which is my main area, really a lot of impressive stuff there on all sorts of levels. Maybe I'll go back to that data question though. Is there an issue about user privacy? Should we be concerned about that, and how do we manage data and use it at the same time?
Yeah, I could start if you. I think certainly there's a lot more focus and attention being paid to this question. You can see that from all the work that's being done, looking at techniques to make sure that we can simultaneously prevent the privacy of information and also try to leverage it for solving problems that we want to solve. I think my feeling is that for a lot of the things that we talk about here, like resource management, for instance, in networks, there's a lot of the network data that it's not clear that it's not really identifiable to a particular subscriber or person. So I think that in many cases the data is probably less sensitive, in that sense, but certainly we still have to be careful when it comes to privacy, and there are new techniques being developed, like we said, where you don't you might be able to leverage data without even seeing it, or to be able to solve problems without potentially impacting the privacy.
If I may jump in here and follow up on that, for me, there are really these two sides of user data that's being communicated. There, in a certain way, the answer is the end-to-end encryption that we do not have fully in place, but end-to-end encryption is what we need for the user data. On the other hand, there's a lot of metadata that is being collected, that's necessary to collect to support the communication and the systems as a whole. I think some aspects of that can be alleviated by strong use of pseudonyms, such that exactly what Michael mentioned, the linking to particular users is not possible that well. But up to a certain level, I feel we have to live with the fact that this data needs to be collected in order to support the functionality of our 5G systems. And it's really about a certain level of pseudonyms and not being able to link to particular people as much as this is possible, but accepting a certain level that needs to be data needs to be collected on that level as well.
So I think both Michael and Christina, I think you both kind of brought up some really interesting points. Michael, you were mentioning the use of multi-party computation and homomorphic encryption techniques, for example, where you don't actually have to see the data to perform analytics on it. Now, I would be very curious to know if you think that there is a path to practical deployment of these techniques in next generation networks. And then Christina, to your question about end-to-end encryption, I think there are, again, both from kind of the government standpoint and industry standpoint, right? They're primarily non-technical, but legal hurdles, right, that have been preventing us from getting there. So I think those technologies exist. We've known about a range of crypto techniques that can address these privacy questions. But really the challenges are, one, the cost of doing that. And of course, the, let's say, willingness of governments and regulators to actually do that. So if you can comment maybe on the non-technical, well, there's a technical challenge, but also a non-technical. So if you could just comment on both.
Yeah, okay. So if, I wouldn't claim to be, I'm no expert when it comes to homomorphic encryption or multi-party computation specifically, but I know that there's the sort of spectrum of techniques that we have considered as well. There are those techniques, and there's also hardware-based mechanisms, right? More confidential computing hardware, as well as I think Christina was alluding to more other privacy protection techniques, like maybe like differential privacy, where
like
you look at aggregates
privacy.
and you can't look at the, you cannot lift out individuals in that sense. So there are a range of techniques. I think some currently are more practical than others. Maybe it's fair to say that. I wouldn't want to speculate on sort of maybe when it comes to particular things like homomorphic encryption. But I think that there are techniques that are practical today and that we can look at, and hopefully there would be a sort of a wider range, and with continued work there would be more options as well.
Yeah, my office has a program running on homomorphic encryption right now called Deprive. And as far as I know, there's still significant challenges in overcoming the computational complexity to perform the math. Even with 1,000x fold increase, it's still expensive.
Just to follow up on that very briefly, the one advantage here or opportunity is that 5G and beyond, you get very high data rates. So, for example, if you look at multi-party compute, that you need gigabit per second data rates to support that. And I think there's an opportunity there. But
maybe we just quickly, I want to go back to that question of Siddharth asked it about end-to-end encryption. Is it fair to say that end-to-end encryption, is that bottleneck just a policy choice, or is there a technical reason why we're not getting end-to-end encryption? And just to clarify my own understanding, my understanding right now is that the data is being decrypted at the base station. So that does prevent a certain point where there can be information leakage. I don't know if somebody who's either Syed or Christina or someone who knows the protocols well can talk about that.
And just to clarify, right, I mean, it's certainly being decrypted by the network operator before it's sent to the internet, right? So, I mean,
yeah, of course.
The ideal would be to have end-to-end encryption between the user and the internet and the website, but the network operator is not involved, right?
Yeah, but getting back to the point that Christina raised, when you put encryption on, you build latency into it, because it takes time to encrypt, it takes time to decrypt. And if you are putting an encryption layer at all 7 of the OSI layer stacks, and you're running 7 tunneled encryptions, you're going to go from something that is very responsive to something that is very slow. And it's tough to unwind that.
Yeah, I think I would tend to agree with the comments on end-to-end encryption. You could have nested encryption to the extent that it becomes, from a performance perspective, too high a cost. I think you'll find that in certain private implementations of the standard, we may find that is indeed a cost certain customers are willing to pay for. I could think of certain military customers, or even manufacturing, or potentially even in the health and life sciences, that those would be problematic. I do think that the architecture, particularly the hierarchical key system that's sitting inside of 5G, does help to isolate to a certain extent. So if you are able to, obtain the key from a G node B, as for instance, it doesn't necessarily mean that you now can use that key to decrypt things in adjacent E node Bs or in network functions that sit upstream from that. So that level of isolation has, kind of percolated itself into the standard, and it does provide at least a reduction in the blast radius. It's always a trade-off, and we have to, at some extent, each operator is going to have to impose some kind of doctrine about what their goals are from a security perspective and what they want to be able to turn on to achieve kind of the commercial benefits they're trying to serve.
So what I can add is that regarding the encryption between your device, EV, and the base station. So you can think of the network architecture as we also mentioned that these kind of network architecture was being considered previously in 3G, 4G, where the base station, which is part of the network, we trust it. So that is a part of the trusted computing base. Now, in the case of disaggregation, where we have the base station can be, physical base station can be shared by multiple parties. So with this kind of network architecture, the threat model is something different. Now, if we say that the data will be encrypted between base station and device, then since base station is securely connected with the core network, we trust it that the communication will be trusted. Doesn't matter, since the data has reached to base station, which is part of the network, that means we are good. But now the architecture has been changed in 5G, and there could be different threat models. So we need to rethink whether is it still a good idea that we follow some sort of a not end-to-end encryption, but definitely that's an area that we should focus.
I'd agree with that. That this disaggregation does present new challenges. It's how does, for instance, should the base station mutually authenticate with the upstream digital unit, and should the digital unit mutually authenticate with the control unit, and all the way upstream, so that there's a chain of custody across your network. And I think you're going to find that at an implementation level, some of those techniques are being done because it's really kind of unspoken in the standards.
Since we're coming up to closing time, Sundeep, should we get like a round of very quick concluding comments?
Sure. Also, maybe when your closing comments, maybe you could just also talk about, there's a number of students here on the panel, maybe some of them looking for a research topic or jobs or careers. If you have any message for them as well, that would be great. So
just in the interest of time, though, I'm sure each one of you have some really fascinating ideas for every student to. But if you could just like them, if you had to pick one topic, right? What would you encourage students to work on? In the next 5 years for a PhD thesis.
Oh, we're ending at 3:15. Is that right? Yes. Okay. Please. Maybe I'll just call them out as I see them on the screen. Michael, you want to just say some final remarks?
Okay. Yeah. So as I said, I'm optimistic. There are great opportunities to introduce new principles. We talked about zero trust and so on in the next generation system. And as for this advice to students, I think this is an interesting area if you're working in getting into security, and now is an interesting time, as was mentioned as well. It's an exciting time for research in mobile infrastructure and defining the next generation systems.
Okay, thank you very much, Michael. Syed?
I want to echo what I said in the beginning, that we should consider security and privacy as the first-class citizens. Unless we do that from the very beginning, we cannot survive. I mean, this kind of ad hoc fixing will not last for too long. And finally, for the students, as I'm a new assistant professor, I have a lot of openings. So I'm super excited to work with you guys. I mean, if you have any interest, feel free to reach out to me.
Okay, Fish.
Yeah, the reason we're even having this discussion is because 5G is that tipping point where cellular has suddenly become critical infrastructure. And so we're worried about it. It's carrying things that are going to be even more mission critical moving in the future as we start to hook up more enterprise services to the system. So it's not, there's no better time to be looking at security as a first-class citizen of the 5G architecture. Where I would advise students to spend their time, machine learning, AI are going to be the sword and the shield, moving forward in terms of preventing security attacks on this kind of infrastructure moving into the future, especially given its large surface area.
James?
Vish stole my thunder. That's exactly what I was going to say. Security is a great area to be in right now, and is you can get a lot of technical depth there, and then pairing that up with an AI ML broad expertise, you can take that and be portable. So I think the two of them together is a very exciting area to focus on.
And finally, Christina, our other academic on the panel.
For people who don't want to do AI and ML.
So word security, cybersecurity in particular, and 5G systems in general is here to stay. I expect we will see a lot of more to come in the future. That's why I believe this is a very interesting field for all the students. The same comment as I did. Reach out to me if you are interested in projects or discussing more about that. Thanks.
Yeah, I just want to add, I know this is of course true for all our industry participants, but for the academics, Christina and Syed, for those of you who are students, you would be fortunate, I think, to work with folks like Christina and Syed. So for those of you who are interested, please apply to them. They do some amazing research. So yeah.
I want to thank all the panelists. This has been a great inaugural panel. Hopefully you have more of these in the future, and we'll see how 5G evolves. And also please thank Seesaw, Steph Daly did a great job organizing this, my colleague Siddharth here, NYU Wireless, NYU Center for Cybersecurity, and all our sponsors, both in industry and federal agencies. All right, and I think that wraps it up.